Hello world, Christian Truther here, and I've got another video for you today, part 7 in our series, multi-part series regarding what is the shape of the world. Can we determine what that shape is? It does have a shape, and that shape is an objective truth, which means it's true regardless of what we think about it, and we're trying to figure out what the truth is and hold on to that. So I hope you're here with intellectual honesty. I hope you're here willing to accept truth when you hear it, when you see it. And before I get into it, some housekeeping. First of all, my rules, which I never read aloud, but the top two are my promise to you, and my bottom two are the ones that I hold you guys accountable to, especially in the comments section, because we are all human beings. We all deserve to be treated with some respect as a result of that. Also, if you haven't watched my first video, I do highly recommend it because, as always, I do cover a different topic with each video. But more importantly, I tell you why I'm doing this, what my methodology is. As always, no cuts, no scripts, no green screens, or anything like that, because I'm not trying to improve my arguments through polish and showbiz. So this is what it is. I'm just talking off the cuff with what I've seen, experienced, and experimented for myself. And I'm sharing it with you guys, and today we're going to be talking about the movement of the sun. But before we get into that, a quick word on the maps. First of all, this is the flat earth map that I'm using, and I use this one because it's analogous to the image that's shown on the UN logo. I know there's a couple of them that are moderately different out there, but this is probably the most popular one that I've seen in all my research and study. So this is the one I'm going with, but really it doesn't make all that much difference. This is the Mercator projection, and as always, this is a lie. It's not quite right, but the people who are on the heliocentric side of the ball understand that it's a lie as well, because the light source, as it gets to the top, spreads out, and so you get an elongation towards both of the hemispheres. But that's just going to happen anytime you try and map something from a round surface onto a flat surface. You're going to get some spreading, some elongation that doesn't actually occur. So this is not entirely right, and so there's some confusion over the maps, but these are the maps that we're going over. So using the Mercator projection is, of course, timeanddate.com. Now, when I took this was on Friday, November 16th, 2018 at 10:42 in 0 seconds UTC. So this was quite early when I took this screenshot. I did it for a particular reason. You'll see why here in just a minute. But clearly, with the sun mostly over Africa, we've got most of South America in daylight, and basically all of Australia just getting setting sun with just the barest sliver, because it's winter time here. This is 2018 in Michigan, so I'm in the northern hemisphere. We've got the sun is more centered over the southern hemisphere, so we're getting more daylight down south and less daylight up north. As this being a Mercator projection, you get the elongation effect, so you can see clearly in this. Okay, so what we do know about timeanddate.com is that regardless of where you are on Earth, this will accurately tell you what to expect as far as when the sun will rise, when the sun will set, and when you will expect noon in your location, or not specifically noon as in the time, noon as in a moment when the sun is directly overhead. So as far as that is concerned, this is accurate. Now whether the map itself is accurate is a different question that we now have to ask ourselves. But at least the sunrise, sunset, and noon times are accurate everywhere you go, any time of the year. So, sun movement on a flat Earth says that it's revolving around an equatorial plane. Sometimes a little bit south, sometimes a little bit north, but it revolves around like this. The globe model says, of course, that the world is spinning, and also the world is traveling around the sun. And here is some problems in the flat Earth model. Remember, we saw all of Africa and basically all of South America, and just a sliver of Australia. In order to make that happen, you'd be having this, and then somehow it curves up. Now, the reason that's a major problem is because the sun is round. From everywhere and every time you look at it, it is round. And a round light source produces round shapes on the ground. Okay? That's universal. And so you're asking a round light source to create something that is definitively not round on the surface of the Earth. Why would light change its properties? Just for the sun. It doesn't make sense, but moving on. Looking at this is the original blue marble taken by the Apollo 17 astronauts as they returned to Earth in December. Okay, so it's about a month in the future, but we're pretty close. And so they're approaching, and there's Africa. You can make out a sliver in this corner right here of Australia, and just the barest outline of a coastline of South America. You can say, well, this isn't working because we saw that basically all of South America was available to the sun's view. Well, let's take a look at this shot. This is going to be from the Discover satellite. It's a weather observation satellite that they say is out past the moon, and that's what makes the difference. So here we have all of Africa. Again, you can make out the bare sliver of Australia. And now you can see more coastline of South America. In fact, you can see backside coastline. So this was also taken November 16th from the Discover Satellites files, which they upload to the internet routinely, and you too can check them out. You can go back in time. You can find this image. So what are we seeing here? This matches the timeanddate.com shot pretty close. Do we see as much of South America as maybe was appeared in the timeanddate.com map? Maybe not quite, but here's the point. And I covered this in my third video on satellite data. As a ball object is moved further away and then optically zoomed in, you will see more of it until you can see it's far enough away where you can see actually the full half of a ball. And to test this for yourself, and I tested it, I used a soccer ball. I used it because it's got those dark colored pentagons that are good reference points. And on my soccer ball, there were pentagons around the outside edge that when it was close to the camera, you could not see behind those dark colored pentagons. You could only see the front part of the pentagons and not the back ends of any of them around the outside edge. As I moved it away and then optically zoomed in, the ball physically looked the same size, but you can now see traces of color, the lighter color, behind the dark colored pentagons. And the objects in the center, the pentagon in the center, was no longer dominating the image quite much. It had shrunk down somewhat. And that is exactly what happens on a ball surface until you're far enough away. And in the original blue marble shot that I showed, the astronauts were traveling from the moon to the Earth, so they were in between the two. In this one, the Discover satellite is out past the moon. In fact, sometimes the moon photobombs the Earth and it discovers imagery of the Earth. So it's got a greater distance perspective with some optical enhancement. And until you get far enough away till you can see the entire ball shape, but you got to understand, the world is just really, really huge. So the round Earth argument is winning strongly at this point, but there's more. There's what we perceive of the sun's movement in the sky. You see, when someone took this shot of the eclipse, the sun appears to be the same size, whether it's down here or up here. And when you have an object that is a great distance away, that would be true. Certainly, the round Earth people are saying we get closer to the sun when it's noon rather than when it's sunrise or sunset. Our distance is the farthest away, but it's such a small percentage that the apparent size of the sun decreases by such a small amount that we don't notice it. But the closer you get with the sun, in fact, most of the flat Earth models call for the sun to be radically closer. You would expect a much greater change in size. And the only reason they're saying that you're losing the sun is as it goes to a vanishing point. But guys, be intellectually honest with yourself. You've never seen the sun actually vanish to a point and then disappear on the horizon. Now, I know there's videos that you've probably seen, and I've seen them too, that kind of showed that activity. But be intellectually honest with yourself. You've never experienced that in your entire life. None of the ancients ever described that behavior from the sun. Ever. What we all observe, and what is the truth, is that the sun appears to be the same size at morning, evening, and noon. Until it goes down, and as soon as it came up, and when it's high up in the sky, it appeared to be the same size. There was no vanishing going on. And we know that cameras aren't as good as the human eye typically at capturing light, so it could be problems with the rigs. I'm not saying that they're all fraud or anything like that, but it could be problems with the rigs. The fact is, the sun doesn't just vanish to a point. It's not a vanishing point. It's just going over a Earth bulge. So, one more word about sun movement. So here I am in Michigan, and in the longest part of the day, which is, of course, around June 21st every year, we get 2/3 of our day, approximately. It's actually 63 point something percent of our day is sunlight on that day. Longest day of the year in my area. So what I did was I went ahead and supplied a track. This yellow track would be the circuit of the sun. And this is my noon. This would be my sunset. This would be my sunrise. Okay? And I measured it out. And of course, I could show you guys measuring it out, but it looks pretty much like 2/3, doesn't it? It's because it is. So, my point is, from my position, you don't think I noticed that the sun is not setting and rising in basically the same location? I mean, here is west anymore, or this is north. It would look to be setting way northwest and rising way northeast. I mean, have the direction suddenly swapped in summer versus wintertime when it's expanded out and it's disappearing instead of way out here, more out here because the shorter days. I mean, the sun's making a 24-hour circuit, so it's got to go all the way around this circle. So the only way for it to disappear is for it to be way over here at these points from my latitude. Guys, that doesn't happen. And if you're honest with yourself, it doesn't happen for you either. This is game over again for flat Earth model. The sun does not back you up at all. It can't be going around a flat plate. The truth is that the world is round. Let that truth set you free, and it will, because there's a trap. The trap is that people will not believe you about plenty of other things in your life and what you believe if they can't trust you about the very real shape of the world. So, until next time, this is Christian Truther, signing out.